Hello, my name is Maria Sepulveda. I'm a professor at Purdue University. And today I'm going to be presenting to you the summary of our research on the development of amphibian poly and perfluoroalkyl substances toxicity reference values for use in ecological risk assessment at aqueous film forming foam sites. The rest of my team is from Purdue University, Jason Huberman, Linda Lee, and also from Geosyntec, Jason Conder and Zachary Pandelides, which have been instrumental in the development of the TRV from this project. The main objective of our work was to develop TRVs for amphibians so that they could be used for ecological risk assessment. We focused on perfluorooctanoic acid, PFOA, and perfluorooctane sulfonate, or PFOS, as the large chain or C8 PFASs, as well as 6,2-fluorotelomere sulfonate, 6,2-FDS, and perfluorohexane sulfonate, PFHXS, as the two shorted chain or C6 PFASs. We followed a series of procedures to evaluate the toxicity, both acutely and chronically, for these PFASs to amphibians. We focused on three main species: the eastern tiger salamander, here as a juvenile and here as a metamorph. Sorry, here's a larva, here's a juvenile. The American toad and the northern leopard frog. Not shown here, we also focused on an additional 6 other species, one of which, the American bullfrog, will be included in the TRV that I'll be presenting in a little bit. Our exposures were varied in length from just a few hours or a few days when we conducted our acute toxicity testing, all the way to several months or weeks and months for our chronic testing. We exposed animals aquatic through the aqueous media, mostly through the water, for gill and dermal uptake, as well as through sediment, moss, and diet. We looked at bioaccumulation and ecologically relevant endpoints such as survival, growth, and development. This table summarizes what I just said in more detail. A couple of things that I want to point out. We also conducted additional experiments with other PFASs and mixtures that I would not be presenting today, as those were not used for the development of TRVs. And the other point I wanted to make is that our experiments range in complexity from very simple indoor laboratory experiments to very complex outdoor mesocosm exposures. In terms of our major findings, bioaccumulation, we found very early on that in our research that larvae rapidly reach steady state with these chemicals, and they eliminate or depurate them also very fast. As many others had already reported, we also found that PFOS was the only one of the 4 that we studied that bioaccumulated, and that's shown here. On the y-axis, we have the log of the bioconcentration factor, and on the x-axis, we have the concentration of PFASs in different colors, and the symbols denote different species: square toads, triangle salamanders, circle frogs. And there's a few things I want to point out. First, what I just said, PFOS is the only one that bioaccumulated. Also, the second point is that bioconcentrations were very comparable across species. And thirdly, that the precursor 6,2-FDS was metabolizing, although not very clearly here because of the log scale, but overall was metabolizing in these organisms. In terms of the TRV data that we obtained in this study, that's summarized in this table. We're presenting NOEC and LOEC screening values based on effects on growth or changes in body mass, because this was the most sensitive, ecologically relevant endpoint that was also more likely to respond in a dose response fashion compared to the other endpoints that we measured. LOEC are the concentrations at which exposure levels, concentrations at which there was a statistically significant effect compared to the controls. We looked at effects. We considered these effects significant and biologically significant between 10 and 20% changes. So in terms of NOEC, we see that we obtain a value of 120 parts per billion for PFOS and a very similar value of 130 ppb for PFOA. For the other two, the C6, they resulted, as we predicted, to be less toxic. So the NOEC values were higher, and indeed we could not find, or we cannot report LOIC values for these two chemicals, as there were no statistical differences between the doses tested and the control groups for the endpoints for body mass. And then in relation to PFOS and PFOA, we are reporting LOIC values of 1,400 parts per billion for both. And those resulted in significant adverse effects on growth of about 14 to 20%. So the key points from this work is that we were successful in developing TRVs for PFAS for major amphibian groups found in the United States. LOIC values for PFOS and PFHXS were estimated at 1,400 parts per billion. Therefore, the proposed US EPA aquatic life water quality criteria of 94 parts per billion of PFOA and 8.4 parts per billion for PFOS would be protected of amphibians. We did not report here LOIC values for PFHXS or 6,2-FTS because none of the toxicity, none of the concentrations that we tested were significantly different from the controls for the effects on body mass. And we also report bioconcentration factors that can be used for food chain modeling of PFAS. Thank you very much for your attention.